Okay, guys, maybe we can just start with a couple of quick introductions for everybody. Sriram, you wanna kick us off?
Hi, everybody. I'm Sriram. I started the EigenLayer project 2.5 years back, and before that, used to be at the University of Washington, Seattle, and run the UW Blockchain Research Lab. Really excited to be here and do this podcast with the P2P team.
Cool, thank you, Sriram. Nima?
Hey everyone, Nima here. I lead the AVS engineering team at EigenLayer. Before this, I was a technical research partner at Polychain. That's how I got introduced to EigenLayer initially. So excited to be here.
Thank you. Okay, and Teddy?
Hi guys, Teddy here. I'm a research engineer at EigenDA within EigenLayer, and I was more recently at Duality, which is a startup that was acquired by a peer-to-peer subsidiary recently, actually.
Yeah, Neutron. Okay.
Yeah.
So Pavel, maybe can you introduce yourself also?
Yeah. Hey guys, can you hear me?
Yep.
Yeah, cool. So my name is Pavel. I'm a member of research team. Previously data analyst. So I'm making different things, looking at different things in the industry. And yeah, one of the main passion is restaking. So happy to see you here. Nice to meet you.
Thanks, Pavel. Okay, and so lastly, me. I'm Stephen. I'm the head of research at P2P. Been in the industry quite a while now. I'm ashamed to say how long, almost. And so at P2P, I'm leading research, and we work on constructing and managing our portfolio of networks that we support, other opportunities, launching new ventures, stuff like this. Long-time fan of EigenLayer and restaking. I think me and Sriram, we spoke early last year. We spoke one time early last year, but we haven't spoken since then. We have like a few things I guess we could talk about today. We definitely have too many things to talk about to actually get through it all at the time, but we'll do our best. Let's just start with whatever you guys have top of mind, whatever's most important for you right now.
We have a testnet running right now where, on the mainnet, we have just staking. You can do either native staking or you can do liquid restaking. You take a liquid staking token and deposit it into EigenLayer. On the public testnet that we're running on Gurley, we have all the different sides of the ecosystem. We have stakers, we have operators, we have AVSs can deploy. We have EigenDA as the first AVS already deployed. So we're doing a lot of tests on all of these different sites and looking forward to bring that to mainnet in the coming 3 months.
Mm-hmm. And so just to be specific here, you're talking about EigenDA or EigenLayer, because EigenDA is launching beginning of April, I think, or early.
Yeah, it's in the next 3 months. Yeah.
So I wanted to ask you guys if you could share a little bit more of your thoughts about AVS other than EigenDA. How you guys are thinking about the rollout for those, and maybe some that are like most interesting in the first 3 months after launch, after EigenDA.
Nima, do you want to take that?
Yeah, sure. So we're seeing quite a few different verticals of AVSs rapidly iterating on testnet, and gearing towards mainnet in the coming few months as well. A few of them are things like what All Layers is doing with restake rollups, what Hyperlane's thinking about in terms of bridging, what Lagrange has been thinking about in terms of stake committees, all the way to things like AI core processors. That's going to be a really big thing this year. So those are just some of the few categories that we've been closely working with AVS teams to think through the designs and implementations for.
Okay, cool. I don't want to jump into the deep end too quickly, but I'd say the way that it's been going with restaking over the last few months is you guys keep introducing caps, hitting the caps really quick, basically setting targets, hitting them very, very quickly. The influence of restaking seems to be growing and growing, or the potential, I should say, of it seems to be growing and growing. And I have one kind of bigger picture question that I'd like to get with you guys, which is about generally restaking's potential influence on like the competitive landscape for security models for / consensus mechanisms. But as like a segue to that, maybe we could talk about ethos and like the recent announcement that you guys made, because that's kind of like a sign of you guys already going beyond Ethereum, right? To like we were talking about this before we started, unsurprisingly already kind of going to Cosmos. So maybe you could tell us a little bit more about that, and we could use it as a launch pad for that other question.
Yeah, I think it's, if you go back to the origins of why we built EigenLayer, it is to build and deploy new consensus protocols. That was the original starting point. We didn't have like all the nuances of the categories that Nima just started talking about, and I think there's much more of to talk about at that time. The simplest version of it is, can you build and run a chain, right? And in fact, for a lot of people, that's what they think of when they think of EigenLayer. When we think of EigenLayer, we're thinking of like running all kinds of services, and chains is not like the only kind of service. But when you're thinking about running a chain, like the pioneer of like, run your own chain is Cosmos. So obviously there is a very natural kind of synergy there, that if you can have a pool of economic security backing your chain, then it makes it really easy to bootstrap and so on. It is in some sense similar to some of the Cosmos roadmap, including interchain security, which I think now is called replicated security and mesh security and other things. There are different models of these showing up, and we want to propose using ETH as an asset in several of these categories. So that's how I would phrase that discussion, which is not so much that we are branching out of Ethereum. EigenLayer was started as a mechanism for using ETH security for all kinds of consensus protocols, and Cosmos is the place, one of the biggest places where you can do those experimentations. And we're really glad that we're working with Ethos. Nima, you want to comment on that a bit?
No, we've just been fairly impressed with how like rigorously they've been thinking about the design space here, and what are some of the nuances there are. So we're just excited for them to hit mainnet soon and fulfill its promise.
Okay. Before like continuing on to that like bigger picture question, maybe actually we could just talk a little bit more as well about like the marketplace for EigenLayer, and then how we can think about the early days for AVSs when they launch, what the dynamics might look like there in the market. How are you guys thinking about that?
Yeah, it is. This is one of the bootstrapping a new marketplace problem where some of the pricing dynamics can be pretty complex. So it is early days for us to comment on what for example, exact parameters of pricing would look like. But the high level that we are going for is more of like an emergent free market of pricing, where AVSs pay a certain amount, and that is going to be distributed among all the restakers. So the restakers then opt in to the extent that that is attractive to them. So that's the kind of like of high level construction. But we are looking at in early days of the markets, these price discovery is pretty difficult. So we are looking at mechanisms to make it easier for price discovery, so that like this doesn't have to be a ping pong of negotiation. Rather, it can be a single parameter that is updated by the protocol or what. We're still under like exploration for what is the simplest parameterization of this problem.
So like maybe we could take this opportunity to talk about EigenDA for a second, because it's going to be the first AVS that's going to launch, and it's going to kind of maybe set the tone or the dynamics for like the supply and demand between operators and AVS. So Teddy, how do you think that might play out? What might it look like?
Well, obviously there are costs to running a node for EigenDA, and so the first goal of any kind of payment and reward system is going to be covering those costs, where the user will pay some amount to disperse a blob, and that will eventually end up in the hands of the operator and the restakers. I guess further question is like exactly where does the pricing sit relative to the market for DA solutions? And we don't have an answer for you on that yet. The general guidance we're giving is that it's going to be competitive, and that it's probably going to be a few orders of magnitude cheaper than Ethereum call data, even with EIP 4844.
Okay. So maybe we can come back to that in a minute. I'd like to talk maybe a little bit more about like comparisons between EigenDA and like Celestia maybe, or other data availability solutions, you know. But like what's particularly important for us at the moment, or particularly interesting, I should say, is we really want to get into like some specifics of the cost benefit of launching your protocol with restaking versus without, right? And I mean, at a very high level, I guess the way that I would think about it is that anything which introduces some optionality, some flexibility, there's going to be a bit of space in there to get creative, you know. And I guess we could think about cost in terms of launch costs. You could think about cost in terms of operating costs. You can get into like more specifics of the actual like tokenomics, like what exactly inflation you need when you're in a dual staking model, you know. So, I mean, for AVS, roughly, like ballpark, can you guys like guess what you think the cost difference might be? Or if not that, how are you thinking about it? Like, what is the pitch going to be there for AVS?
Yeah, I think one way to kind of like understand this is you can fix the cost and then like look at how much more value you can get, or you can fix value and then ask like how much fee reduction are you getting. I think it's easier to think about like fixing a fee and then asking, are you getting more value because of EigenLayer? And I can explain how that is the case. Imagine you have 1,000 protocols, each of which have $1 million staking. Why do they have $1 million staking? Whatever fee they are paying is fundamentally able to satisfy $1 million staking. Maybe upstream of this discussion is the assumption that the dominant cost of actually running a protocol is the cost of capital, not the cost of running the software. There is a cost to running the software, but it's, for most protocols, that is much smaller than the cost of actually getting people to commit capital that is staked. So, with that model, you can think of like, I have a protocol, I have enough fees to cover $1 million of staking. Like, let's say that's the case. Now, if you have 1,000 of these protocols, each of which are doing exactly that, they are having enough fee to cover $1 million staking. Now you aggregate all of them into a common pool and you have $1 billion staking, which is restaked across these 1,000 protocols. Now, all of them are better protected because to attack any protocol, I need to acquire a majority of 1 billion. If I go and attack the protocol, I will get slashed for a majority of the 1 billion, all of that. So economic security has hardening at scale. Like the more the pool that you're operating together, the better it is. So now you can say, oh, because you're getting this benefit, you're getting the pool security of 1 billion, maybe you're willing to pay a higher fee. That's one way of thinking about it. Or the other way of thinking about it is even if all of them pay half the fee, their pool security is $500 million, which is still better than each of them kind of having 1 million. So there are various ways to slice the cost and the value and fee. And I think that is what we are leaving it up to the emergent market. But the understanding that there is more value in aggregation, that is what we are kind of like driving home. And we're seeing that resonating with a lot of developers. Because, when you opt in as a new protocol into the network, you could get the potential full pool security because you are not unilaterally like paying the capital cost of it. Together, all the protocols are paying the capital cost of it. And I think that is a very attractive proposition. And I would say this is one of the dynamics that attracted, a lot of dApps to just go build on Ethereum. because you already have a pooled security there and you just like go and throw your dApp on top of it. It's a little bit more overhead in EigenLayer to like launch your like protocol and get all the stakers to opt in. But it, over time, we want to make this really, really simple.
That is a very, very nicely done explanation. You've had some practice at that. Yeah, I mean, Pavel, do you want to follow up with a question there? Do you have anything you want to ask, or should we move on?
I guess I need to think a little bit about what Shriram said, because
Okay.
it's really...
Okay.
Yeah. So one other like dimension that I didn't talk about there is are you staking your own token versus are you staking ETH? And like for a kind of like a protocol, it is material, because is the fee going to my community? Is it going to some other, participant? And the thing is, for a certain amount of economic security, if you want people to buy and stake a new token, there is a lot of volatility and other things embedded in it that people are taking a bet on. So you have to give a higher percentage APR for people to like actually stake those tokens. For something that's a much more stable asset like ETH, and there's a lot of people who are long ETH, like they would be much more comfortable staking ETH. So that's one dynamic. But on the other side, there is a kind of like thing that cuts against like the core principle of EigenLayer, is that value accrual to my token versus value accrual is like going outside the ecosystem. And the way we think about it, or like, solve this problem, is by using dual staking. And the idea is EigenLayer natively provides a way for you to stake your own token and ETH, and then like, have a quorum that covers both of these different types of tokens. What this does is, because, and of course, like, you can decide how much of fees goes to the ETH quorum versus how much of fees goes to the like your own token quorum. And what this does is basically control how much of ETH security you're buying. And the nice thing with this is, initially when you're bootstrapping, maybe you need a lot of ETH quorum and you have to pay a lot of fee because it's a risky protocol people are opting into. Maybe over time, especially in the pooled security model, you don't need to pay that much to be part of a larger pool of restaking, because your protocol is more vetted, people trust it, it doesn't have crazy slashing things, and you can redirect more value to your own token. So these are the kind of dynamics. There's another interesting dynamic, which is what I call variable security or elastic security, which is that protocols don't demand a constant known amount of security that you know what it is. Like imagine I'm running a bridge and I need more staking than my weekly transaction value to like protect my bridge. My weekly transaction value may fluctuate between 10 million and 200 million. Do I have a 200 million pool, therefore always standing guard, or can I have like a much bigger like pool of like stake, in EigenLayer, and just borrow exactly the amount that I want on a kind of weekly basis? So we call this elastic scaling of security, just like, Amazon is elastic scaling of compute. Right? You just buy exactly the amount of compute that you want from the larger pool of compute. EigenLayer gives you like a pool of security that you can draw like the exact amount that you want. So this lets you average across all the different variations in different pools.
That is super cool. That's really interesting. And it kind of, we've touched on a couple of times, like cost of capital, and now, in this like elastic security, I think you said. It brings me back to this like bigger picture question that I wanted to ask you guys about the impact of restaking on the competitive landscape. So, I mean, it's quite obvious that restaking is a value add to Ethereum base layer, let's call it, or the Ethereum security model, or Ethereum consensus mechanism, however you want to describe it. So Ethereum already has this like snowball working for it with, the whole scaling roadmap and L2s feeding into it. That's clear. And like restaking is adding to that now. And it's making the capital more productive. It's making it more efficient, right? So, and now we have like Ethos is kind of entering Cosmos, right? It's clearly now in like direct competition with the other forms of shared security there. And it kind of starts to raise the question of, if you're looking at Ethereum competitors, let's say, you look at Polygon, or you look at like even Avalanche, or you look, whatever. To what extent do you think restaking impacts the competitiveness of these alternative security models?
The high level there is if you think about it, like there's two questions there. Like one is, are there specific additional advantages in different ecosystems that could sustain them? And I think the answer to that is yes, right? Because, for example, Solana has its own group of developers and network effect around that and a common composable state. But if you just look at the security models, which were much more about, hey, I have a pool of security that can be lent to other things like the Polkadot parachain, the Avalanche subnets, the Cosmos mesh or interchain security, I think we can compare these like different types of security lending models. And what we have strived to do with EigenLayer is to make it the most flexible. That's the kind of goal. So making it most flexible basically comes at some cost that we don't control, like end-to-end experience. We don't control the customer directly. Like you just mentioned Ethos, right? Ethos is building a Cosmos interface for EigenLayer. So they control a lot of that. But by making our own layer very, very flexible, so you can build basically any of those other models on EigenLayer, but the reverse is not true. And that's what we are aspiring to. And the reason is that we think that there's two main things that's going for EigenLayer, which is Ethereum as a stable long-term source of value that people are willing to hold and, bet on and stake. And there's a convergent dynamic around ETH. And the second one is that when you have all these different systems building on a common substrate, the adjudication of when things go wrong all can be done in one place. And this is really important. Other models of security like mesh security have borrowed security from many different tokens residing on different chains. So any adjudication of slashing has to now be written on all these different chains. It's just a much more complex, intricate mechanism. Whereas EigenLayer's view is, just take the Ethereum roadmap and Ethereum as the settlement layer. In our view, Ethereum as the trust layer and the adjudication layer, like it adjudicates disputes. That's all Ethereum does. And ETH as the asset is, because ETH as the asset is used, the adjudication of Ethereum is final because Ethereum says where ETH is. So those two have to be coupled. What the token of trust is and what the adjudication layer is. And so we are going for flexibility and neutrality, and that maximizes the scope of other people trying to do other things. And Ethereum already has one more thing which is going for us, for EigenLayer, has the thinking of layers. Like it is a layer 2 roadmap. Already lots of people building things on top of Ethereum. So it's not a new paradigm. It's not like, people don't understand it. And that helps us a lot. Related to, let's say, you want to go do this on Bitcoin, let's say, and there's no like thriving layer 2 ecosystem there. So that's how we think about it. And Nima, do you want to add anything?
Yeah, one thing that I was going to touch on specifically is this separation of concerns that you just alluded to with the base layer being an adjudication layer versus what we're already seeing with different types of core processors or like VMs experimenting in giving developers different, developer experiences and what that means for, end consumers. So I think we're just at the beginning of that. In the next few years, we're going to see a lot more of it, which is pretty exciting.
Okay. I think it might be a good point to, while we're on the topic of comparisons, and like specifically, we're kind of talking about like cost benefits of things as well, I guess. Cost of capital. Teddy, before the call, we started talking about EigenDA, and like I'm kind of interested how you think projects might approach what their thinking is when they're trying to select a data availability layer. Is it as simple as, the order of priorities? Is it as simple as cost, security, ease of development, or something like this? Or do you think it can be different?
Yeah, I mean, I would put emphasis on those that you mentioned. I would also mention the scaling strategy of EigenDA is different from many other solutions in the space. EigenDA takes a strategy that is sort of analogous to dank sharding in the sense that as more operators join the network, the throughput of EigenDA increases. And so unlike some other DA solutions that are consensus-based, we will have a very clear path to scaling beyond sort of like consensus limits of DA. And so there's that, there's cost. This scaling strategy also reduces cost a lot because rather than sending a blob of data to every single node in the network, you're only sending chunks of that blob to a subset of nodes that have been selected for that specific blob. I think also the ability to reconcile different blobs within the same system, which is settling to Ethereum, is another big advantage that rollups are looking to us for. It's starting to become clear that shared sequencing depends on shared DA settlement. And so in the future, we might be able to use the fact that EigenDA all settles within Ethereum to help these various interchain solutions work well.
Yeah, that's awesome. I think, we talked a little bit about the more, Teddy talked a little bit more about the foundational stuff, but there's a lot of practical stuff which I'm seeing when talking to like customers who are choosing to build on EigenDA. I would say the three kind of practical things are, the number one is we have reserved bandwidth. So one of the things that happens with the shared DA layer is you lose kind of, you have to compete for a common resource. And that's always like, who knows, price goes up or down, there's suddenly contention, UL Labs does a drop, and now your fees went up for your customers. Like, this is a big problem. So number one, reserved bandwidth. So in EigenDA, you can reserve your long-term bandwidth and say that I have X% bandwidth just for myself. And that's a really interesting model. The second one is you pay for you can pay for reserve bandwidth in ETH, but also because it's a long-term arrangement, you can pay for it in your own token. So this means you're starting to look more and more like an L1 because, if you're an L1, your costs are dominated in your own token rather than your costs are dominated in some exchange rate risk between your own token and ETH or some other token. So that's the second thing, is pay in your own token. So you reserve your bandwidth and then you pay in your own token. And these two, like the reservation and pay in your own token, we're able to do because of the fundamentals that Teddy laid out, which is that we are highly scalable, our cost basis is low, we have very high throughput, so we can chunk it up into reserved slots that you can kind of sell, even if people are not necessarily using it all the time. And then the third one, which I think for some of our customers is maybe the most important, is dual staking on EigenDA. Like, I'm building a rollup, and what is the utility of my rollup token? And today, like for most rollups, there is no such thing. And EigenDA provides a very simple single-click method to create utility to your own token, which is you list your token into the EigenLayer platform. And in EigenDA, your data is confirmed available only if your internal token quorum, your native token quorum attests to it, and the EigenLayer general quorum attests to it. That is a really, really superpower for a lot of rollups because firstly, it actually has a real benefit. The real benefit is this double checking of like the data. You're getting the better of the safety from two different communities, from your own token community and the broader Ethereum community on EigenLayer. So that's really helpful because data availability, safety is very important. But it also provides a native kind of utility for the rollup token. Now it looks almost exactly like a layer one in terms of economics. Your token's used for staking. You're paying for fees in your own token. You have no contention for the amount of bandwidth that you reserve. You're kind of king of that bandwidth. So you have very, very similar properties to a layer one and become highly competitive in the marketplace because of EigenDA.
So that kind of makes me think about another like point that's particularly important for staking service providers like us. And one of the things that caught my interest with EigenLayer really early on was creating alignment between L2s and like the ETH validators in L1. And so, yeah, maybe you could speak to that a little bit, and how you think, what potential you think there might be for linking the economic activity of L2s to the validators of L1.
Anima, do you want to speak to this?
I'm not sure exactly what is the. Can you rephrase the question maybe a little bit?
Okay, so basically, you have like L2s in their current form.
Yep.
They are maybe not decentralized at all,
mm-hmm.
or they have limited incentives to decentralize. And then when they do decentralize, they might only require a very limited operator set.
Mm-hmm. That
operator set may also not feature, typically may not feature staking of any kind, right? And so in this case, for staking service providers like ourselves or holders of ETH, let's say on L1, there's kind of no entry point there for you to participate and to gain exposure to the activity in the L2s.
Right.
So yeah, I'm wondering what you think is the potential for restaking to create a link between these two and an opportunity, let's say.
Yeah, no, this is a very interesting area. Two of the properties that are fairly interesting to think about for EigenLayer providing is both the broad network of validators, right, that the protocol enables developers to tap into, but also just like the crypto economic bond that becomes viable, right, to use. So when you combine these two, what you end up seeing is folks can more practically think about how decentralized sequencing ends up happening, right? A few teams that we've talked to who are thinking about the various different designs of how AVSs can be built to enable this, like Altlayer being one of them, right? It just levels a playing field for how you can give rollup teams this capability with much lower cost, effectively. That's at a high level speaking.
Okay. Yeah, Shreem, you want to add something to that?
Yeah, for sure. I think for many of the layer 2s, when they're thinking of auxiliary services could be like sequencing, could be finalization, could be bridging. For all of these things, a layer 2 is like basically, hey, we are getting Ethereum security. And what dimensions are you borrowing the security in? The more dimensions you can borrow the same security in, the simpler and better it is. And that's why I think we're seeing roll-up related services built on EigenLayer being one of the first categories, is because they're branded on Ethereum security, and now hey, I can do this. For example, Altlayer is one of our partners, which is building this bundle called a restaked rollup, which does sequencing and finality or fast finality using restaking. So that's an example, and also watching for your optimistic rollup. So that's a really interesting example of how people are thinking about borrowing Ethereum security to brand the rollup itself as a consistent source of security.
One other thing that's particularly interesting in this domain, I think, is there is a team that is building this concept called proof of location, right? Where for any L2s or any sort of like infrastructure player in the space, if they care about, I guess, how exactly decentralized your sequencer or whatever is, right? They can act as a service provider to be like, hey, I can provide you this guarantee of like where my validator is actually located. So that's, I think, just becoming, just getting onto people's radar in terms of how they can add this as a dimension to how they design their services.
I remember that project, actually. I was on a call with them before. Now I can't remember the name. Are you able to share that right now?
Yeah.
Is that public information yet? Or what was the name of the project? Is it public information yet? Or
sure.
Yeah, the proof of location protocol is Witness Chain.
Yeah, Witness Chain. There we go.
The spin out of Princeton.
Yeah. Yeah. So Yeah, AltLayer is a project that we're particularly interested in as well. So I just want to take a pause here, and we can edit this out. Okay, I want to see if there's particular points that you guys want to try and hit in the last 5 minutes. I think we've gotten through most or nearly all of the questions that we set in the potential topics. So is there something, and this is a question for you as well, Pavel, because we haven't gotten a chance for you to speak with you yet. Is there anything that you guys want to talk about in particular for the last few minutes? EigenDA, EigenLayer, anything?
In fact, we passed the point regarding the EigenLayer and Cosmos ecosystem and whether EigenLayer makes Ethereum ecosystem more competitive comparing to other ecosystems. And actually, I just wanted to touch this point once again. From my point of view, it might be that EigenLayer actually amplifies the convergence of ecosystems. So looking at Ethos example, we can see that Ethereum ecosystem kind of merged with Cosmos ecosystem. Now from the prospect of security, there are different and other things like interoperability that happens on Axelar, on other projects that are bridging. So I'm just thinking whether restaking as a concept, I'm also including mesh security here and shared security model, is a thing that actually brings different settlement execution layers together, and we can come to in some future we'll come to the situation that we have some great pool of security for all the things that happen on the blockchain. And maybe EigenLayer is a candidate for this. Maybe there will be a bigger construction that includes EigenLayer. What do you guys think about that?
Yeah, I completely agree. I think that restaking allows stake to be put to more work. And so that necessarily allows various projects to share security, which aligns projects better and is more efficient in terms of the stake itself. And yeah, I think that the world that we live in today is one where every single chain or AVS has to bootstrap its own security using their own token. And so to move from that world to a world where you can start an AVS based on ETH security by publishing an AVS and lobbying people to restake to you is a world where in general chains are more aligned with Ethereum and each other.
One way to phrase our vision for what we're trying to build is to look at how the web application development evolved, right? If you're building a web app in like 1995, you're building the server, you're building the payments, you're building identity, you're building the database, and then you're building, whatever you're building, a bookstore. In 2023, you would basically, or 24, you would basically use, something like AWS for cloud. You would use a login service like OAuth. You will use a payment service like Stripe, or you will use a database service like MongoDB, and just build the small thing you want to build. So it massively increases the rate of innovation. So we are not thinking of these as, so when people think of the modular world, and if you try to apply this to the crypto world, you're basically in 1995 today. You have to build a chain. A chain is basically like everything together, right? That's how people are thinking about it. So I think it's a misnomer for us to be thinking about chains as the fundamental unit. We think about, already people think about the modular roadmap and they're saying, modules are the fundamental unit. But they think there are three modules like data availability and consensus, whatever. We think, and by just looking at the last 25 years of the internet, there were thousands of successful SaaS, software as a service solutions built on top of like the cloud. And that's what we think will happen. And that's what we want to be a substrate for. So we are not at all thinking about chain as the fundamental unit. That's why when I was saying earlier, that was how we kind of That's the simplest use case that you can think of, is build a chain. But build services, and each service, all these services can then be concatenated to form an end user customer oriented service. That's the end goal. So, so now you want to build an end user customer service, which is a game or social or whatever. Say, oh, I'm using that AI inference. I'm using this bridge. I'm using that login protocol. I'm using this proof of location protocol. I'm using that other thing. And then I tie all of them together. And all of them are on a common security base. So you're not like, if they were all on a disparate security base, you get the worst of the security of all the services that you depend on. If they're all on a common security base, you can actually make this work. So that's the EigenLayer vision, is to make Ethereum the decentralized cloud for all the services to be built on.
Yeah, and kind of like wrap that in a slightly different lens, I would say. The common services that Sriram is talking about, compared to the common security pool, right? In the middle is effectively a way that a lot of developers have been able to think about this is bringing the functionality of these distributed systems outside of the EVM effectively, right? So that's kind of where these two sides meet in the middle and are able to kind of go to market.
I'm glad that we got to this point, because it was the way that EigenLayer had been pitched that really made it click for me when I first heard this. So yeah, I think the analogy is awesome, and yeah. Anyway, it's really cool. So I wanted to ask you, Teddy, also about like throughput on EigenDA and like scaling rollups to support onboarding like lots of users. Could you tell us a little bit more about that?
Yeah, sure. So I think in the back of my mind every day when I'm sitting down at my desk to work on crypto in general, I'm working towards this goal of onboarding the next billion users. Like, this crypto thing that we're working on will not be useful unless the world uses it. Like, if it ends up being just sort of this thing that it is today, which is financial infrastructure as an alternative to the main system, that's not going to be good enough. We need people to be sending each other crypto instead of sending each other Venmos. Hopefully it's USDC or whatever. But I think that if we can't develop some kind of scalable solution, like really scalable, like we're talking about Web 2 scalable, then this is not going to work. And so that's why it was actually really heartening to work with a company called Layer N, which is planning an integration with EigenDA. This past week, they did a speed test with EigenDA and found that they could post around 11 megabytes per second to EigenDA in transactions. And so what that translates to is roughly 100K transactions per second. And this is starting to get on the order of magnitude that's required to run major centralized exchanges, but also sort of like TradFi exchanges, where you just need to be able to publish transactions as soon as they come in, without having to wait for consensus, without having to, go through the complexity of the standard L1 procedure. And so I think that EigenDA is a major piece in the puzzle for getting to this milestone of the next billion users.
Cool. I saw that announcement actually, and it's pretty exciting. Okay, I think it's a good place for us to wrap up. I think, are you guys planning to go to ETH Denver? Yeah, are you many people going, or?
Lots of the team are going, yeah.
Lots of the team going. Okay, likewise, we are going to be, I think, 4 or 5 or more people there. So, yeah, we hope to see you there. And if you want to, do you have any events that you're organizing? I think we might be doing a side event with you, actually. Are there any other kind of events that you guys are organizing?
Nima?
Yeah, we have quite a few planned, which we'll be publicizing in the next few days, for sure.
Okay. Yeah. I thought you might want to plug them, but no worries. Okay. All right. Thanks for taking the time. I'm glad that we got to cover everything that we wanted to.
I can answer that one.
Yeah.
Yeah.
Okay.
So we're hosting a Rollup Developer Summit with Polymer, which is going to be
cool.
a full day in Denver where we talk about rollups and how they potentially can build on EigenDA, but also some of the technology Polymer is working on, and potentially some of the technology AltLayer is working on with restaked rollups. So if you're interested in that kind of thing, swing by.
That sounds cool. Okay, put it in the calendar. Okay, so thanks again. Yeah, I'm glad that we got to get through, everything that we wanted, and it's kind of enlightening for us. Got some very concise explanations of like the value proposition of EigenLayer and of EigenDA. So I'm glad we got to talk about that with you. Okay, thanks for your time, guys.
Thank you so much, Stephen and Pavel. Really appreciate being on the podcast.